Hi, Year Sevens. I'm going to be doing some more collecting like terms with you, but this time we're also going to be looking at powers, division, multiplication, and some of those can be a bit tricky at first. Collecting like terms, we've been doing this in the last video. I got 4 apples and 2 apples is 6 apples. 7 bananas and 3 bananas is 10 bananas. Now, on collecting like terms, we've got a constant 4 and a constant 2, so that's going to be 6. 5 xylophones plus 3 xylophones is 8 xylophones, and plus 6. Okay, we can collect 4 and 2 because they're just constants. 3 zebras plus 1 zebra is 4 zebras, and 2 yachts plus 4 yachts is 6 yachts. 7 cats minus 7 cats is 0 cats, but we don't have to write anything there. We've just got 5 dogs take 1 dog is 4 dogs. 3 marbles minus 2 marbles is 1 marble, and 5 plus 6 is 11. I've got minus 2p and minus 3p. You need to think about the number line. If I've got minus 2 and I subtract 3, I'm going this side, so it's more negative. In fact, it's negative 5. So we've got negative 5p, and q plus q is 2q. We can collect like powers as well. I've got 4x squared, so x squared is a term, another term minus 2x squared. So we need to collect the pronumeral with the power. So that's going to be 2x squared. And we've got 3 xylophones plus 3 xylophones is 6 xylophones. So it's got to have 6x there. Again, we've got ABs, like terms, okay, and we've got 7 of them. 2 apples plus an apple is 3 apples. 6 apples plus a squared plus a cubed. Well, the a squared's by itself, the a to the power 3 is by itself. There's no like terms, so it's simply the same. 6a plus a squared plus a to the power of 3. What a lot of students might do is they might just add these together. 3 plus 2 is 1. No, it's not. It's not equal to 6a to the power of 6. a to the power of 6, a to the power of 6 is a times a times a multiplied by itself 6 times. Okay? Minus 4 xylophones minus 8 xylophones. Well, you can't have minus 8 xylophones, but again, we've got to think about the number line. Minus 4 minus 8 is minus 12. 2 yachts take 3 yachts. Well, again, we can't have negative yachts. Okay, but we can have negative y. So it's 2 take away 3. 2 take away 3 from your indices unit is negative 1. So we've got negative 1y, or just negative y. Let's simplify with multiplication, including powers. Always multiply the numbers first. 4 times 2 is 8. And there's an A, B, and a C left over. So that's A, B, and C. 12 threes are 36. And we're left with XY. 4mn times 3pq. Well, 4 threes are 12. And we've got M, N, P, and Q. 4 threes are 12. Now let's look at this a squared. A squared times a. Well, that's a times a is a squared times a again. How many a's do we have? We've got a to the power of 1, a to the power of 1, a to the power of 1. we add the powers, so that's going to be a to the power of 3. Okay, so a squared times a is a to the power of 3. You'll get better at these as you do more. 2 12s are 24. M squared times m cubed. M squared is m times m, and m cubed is m times m times m. It's not 5m, it's not equal to 5m, because we're multiplying. It's equal to m to the power of 5. We simply add the powers. Okay, so that's m to the power of 5. And p times p squared, well, there's a little 1 there. It's p to the power of 1. Add the powers, becomes p cubed. X to the power of 6 times x squared is x to the power of 8. And don't forget the 3 out the front, x to the power of 8. Now, a half times b times 6, we could write that as a fraction, a half times 6. Well, 2 goes into 6 3 times, doesn't it? So it's going to be 3a cubed b squared. We can't do anything. We can't add those powers because they're different terms. They're not like terms. Okay? 3 3s are 9. M squared times m squared is m to the power of 4. And p to the power of 1 times p to the power of 1 is p squared. 5 5s are 25. N times n is n squared, which is n to the power of 1 times n to the power of 1. We add the powers. And m to the power of 1 times m to the power of 1 is m squared as well. Again, 4 2s are 8. And a times a is a squared. Oops. A squared. And c times c is c squared. Notice that the ca times ac, it's the same thing. It's just multiplied in different order, but it's still going to be the same result. Now let's look at brackets, and it's a little bit different because if I have x cubed, that's x to the power, that's x times x times x. I'll put it in brackets. If I square that, notice that we're multiplying it by itself. How many x's do I have? 1, 2, 3, 4, 5, 6. So in brackets, we multiply the powers. So let's go ahead and do that. Let's go do that for all of these. 6 squared is 6 squared. 2 times 2 is 4. 5 times 2 is 10. X times 2 is 2x. 2 2s are 4. 2 2s are 4. We're multiplying the powers. But what we have to do as well is we need to write a 1 here. Well, that's a little bit too big. That's a little bit too big. Let's see if this works. Yeah, we need to write a 1 there. Technically, that's 4 to the power of 1. And we've got 3 to the power of 1, 2 to the power of 1, and so on. So let's work these out. What this is it's 6 to the power of 1 to the power of 2. Well, we multiply the powers. 1 times 2, and 2 times 2 is 4. And we're not going to leave it as 6 to the power of 2, because 6 to the power of 2 is 6 times 6, which is 36. So we can simplify it even more. That's going to be 36x to the power of 4. X to the power of 5 times 2 is x to the power of 10. 2 times x is 2x, so it's just going to be 3 to the power of 2x, and we can't simplify that anymore. 4 to the power of 1 to the power of 2 is 4 to the power of 2. M to the power of 2 twos are 4. So again, in brackets, we're multiplying those powers. 2 twos are 4. 2 twos are 4. 3 fives are 15. 4 threes are 12. 3 fours are 12. And 2 twos are 4. Okay? So again, though, we've got to multiply that number to the power of 2. Y to the power of 1 times 2, which is 2. And Z to the power of 2 times Z to the power of 2 is Z to the power of 4. But of course, we need that to equal that, and we can equate what 5 squared is. 5 squared is 5 times 5, which is 25. Y to the power of 2, Z to the power of 4. 2 to the power of 5, we might need to do that over here. Without a calculator, we can do it. It's multiplied by itself 5 times. Okay, so 2 twos are 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, so hopefully you can do that to the side if you have a test. 1 times 5 is b to the power of 5. C to the power of 3 fives are 15. 3 to the power of 1 times to the power of 3 is 3 to the power of 3. A to the power of 12. And 3 to the power of 3, let's do that. 3 times 3 times 3 is 27. A to the power of 12. 2 to the power of 4. Well, we did 2 to the power of 5. 2 to the power of 5 is 32. Well, if I was to do that 4 times, we're going to get 2 twos of 4 times 2 is 8 times 2 is 16. So 2 to the power of 4 is 16. It'd be nice to know the powers of 2 up until the point of maybe 2 to the power of 6. 2 to the power of 6 is 64. 2 to the power of 5 is 32. It's good to know these. It's good to know these ones because you do use those a fair bit in maths. 2 to the power of 3 is 8, and 2 to the power of 2 is 4. And of course, 2 to the power of 1 is just 2. Anything to the power of 1 is itself. So that's going to be m to the power of 12. And over here, a half to the power of 2. Well, that's interesting. Let's do it like this. Okay, 1 to the power of 2 is 1. 2 to the power of 2 is 4. So that's going to be 1/4. Or we could do a half times a half. Multiplying the top and bottom gives us 1/4. And x squared times squared is 2 plus 2, which is 4. So that one's a little bit trickier because we've got a fraction. We've already done those. Let's simplify with division now. Notice if I do this longhand, and I think you should do it longhand for a while, it's x times x times x over x. Now you can see here that we've got 3 x's on the top and 1 x on the bottom. Well, look, that's going to cancel out with one of those x's, and we've got x times x, which you know is x squared. A to the power of 7 is a times a times a times a times a times a times a, and dividing by a squared is a times a. Now, if we cancel out one of these a's, we can do that because we're multiplying all the terms. Cancel out another a. How many a's do I have left? 1, 2, 3, 4, 5. So that's going to be a to the power of 5. Getting a bit trickier now. Okay, what we're going to do is we've got to subtract the power when we're dividing. Okay, so m squared over m cubed, well, that's just going to be, if we like, we can go m to the power of 2 subtract 3, which is m to the power of 1. Now, it's interesting. If I got m to the power of 1, we can change m to the power of 1, negative 1, to 1 over m. Okay? So it's worth noting, if you've got m cubed on the bottom and m squared on the top, that's going to be m to the power of negative 1, or that's going to be an m on the bottom. 15 divided by 3 is 5. And don't forget the p by itself, which is 5p over m. Again, deal with the numbers. 8 goes into 24 3 times. X cubed divided by x squared is just x. And y to the power of 5 divided by y to the power of 3 is y to the power of 2. When you've got this divide symbol here, you really want to just turn it into a fraction. So 6RST divided by 2RS. Notice that the R's and the S's cancel out. We've got 6T divided by 2. Well, if I was to have 6 turtles and I divided by 2, we're going to have 3 turtles. And it's just 3T. 5MP divided by 15M squared. The M's are going to cancel. 5 goes into 15 3 times, so that's just going to be like 1p, which we don't have to write 1p, by the way, over 3. And m divided by m squared is just m on the bottom. So we don't write 1p, we write p over 3m. Finally, we've got a couple more. 5 goes into 24 times. Let's leave that in the bottom of the fraction, on the denominator. X cubed divided by x squared is simply x to the power of 1, which is x. Again, a to the power of 2 divided by a to the power of 1. We subtract the power 1 from 2. So that's just going to be a to the power of 1, which is a. 7a, and don't forget the b cubed by itself, and the c. We can't collect like terms. We're not multiplying or dividing like terms. So we just have to leave that like so. If I have this one over here, 28m cubed, n squared divided by 21, m to the power of 4. We want to simplify by, what's a number which goes into 21 and 28? Well, that's going to be 7. So let's divide top to bottom by 7. When I do that, 7 goes into 28 4 times, and it goes into 21 3 times. So we've got 4/3. Okay, now let's work out what the pronumerals are. M cubed divided by m to the power of 4. If I could write it out long ways, m times m, you might be worth doing this. M times m times m times m. Notice that we can cancel out 3 of the m's, so we've just got n left. And don't forget the n squared goes for the right as well. So that's going to be 4n squared over 3m. Now I want you to pause the video, and I'd like you to try 10 by yourself. Okay, so pause the video now, and I'll see you in a second. Hopefully you pause the video. 2 goes into 8 4 times, and I've got a divided by a squared is a over a times a, and we've got a c divided by c to the power of 3, which is c times c times c. These c's cancel out. I've got 2 left. Well, don't have 2 left. I have c squared left. This a cancel out with that a. So all we've got left on the numerator is 4. And on the bottom we have a, and c times c is c squared. Okay, so hopefully this 20-minute video we've had a look at simplifying with division, including powers, simplifying with brackets and powers. Notice that they're different. I'll repeat, x cubed is x times x times x, but that squared, we multiply it by itself. So again, over here, we don't add the powers, we actually multiply them. 3 and 3 is 6, so that's x to the power of 6. So you're going to have to work on those ones. And obviously the trick to doing these is multiplying the numbers. Okay, so the number 4 over here, 4 squared is 16. Okay, so I really should have made that a 16, m to the power of 4. 5 squared is 5 squared is 25. 2 to the power of 5 we worked out to be 32. 2 to the power of 5, that's 1 times 5 is 2 to the power of 5. And again, we simplified all those expressions. All right, hopefully you've learned a little bit more about simplifying algebra expressions. In general, multiplying powers and dividing by powers can be a bit tricky at first, but you need to practice these. So I'll get you to try the ones in your booklet once you've had a go at these.